All right. I really want to get to the word problem, so this is just for those of you that need a refresher. You get to see one more time how we do regressions. Intro to regressions. Okay, so far you were given the equation, you entered it into y1, use second trace to extract information. In this lesson you will learn, make sure you write this down, guys, to determine the equation that will best model, right? You will determine the equation that will best model the scenario. You are finding the curve of best fit, okay? Line of best fit is when it's linear, but if it's at all curving, then we call it curve of best fit. To access any of the above regressions, we press Stat Calc. Let's do that right now. So quit whatever you're, right? Quit whatever, go back to the home screen. So just second mode to do that. Then press Stat. There's the, it actually has to do a lot with statistics. So Stat. Then you go sideways to calculate. And watch this. It starts on the fourth option. We're going to deal with linear regression, quadratic regression, cubic regression, but we're not done yet. Keep going. We're going to use the ninth one, the exponential regression as well as sinusoidal regression. So we're going to use a bunch of regressions here. But for now, I don't want to overwhelm you. Right now it's just linear, quadratic, cubic. Those are our only three options. And the nice thing is the province tells us most of the time which one to use, okay? So that's where we're going to draw from. And how do you use those regressions? Okay. This is essentially what every regression calls for. Quadratic regression, for example, it asks you for location of the x values. Where did we normally put the x values? We usually put them in L1. It's basically a spreadsheet, right? You want the location of the y values. We usually put them in L2. And last but not least, you want a place to store the equation. We usually use a y1 to store the equation that you're going to make. You're not going to make it, the calculator is going to, right? And you got to make sure that they're separated by commas. So I will make it even more apparent that there are commas there separating these three entries. Okay, so we're going to do a regression together. And here is the step-by-step way of doing it. Page 33, you got it? Yeah. I will tell you that this is the long version of doing it. I will show you a bit of a shorter version of entering all of this. So this is what we're going to do. We're going to try to make a regression for these points right here. A line that can connect these points. So guess what we do? Right off the bat, you should realize, oh, I've got points. I don't have an equation. We're going to type all the x values into L1. We're going to type all the y values into L2. How do you go about it? I'll quit everything I'm doing right now. You go Stat, then you go Edit. Okay, that's what it says. The second point right here says Stat, Edit. Then you see your L1, L2, all the way to L whatever. Lots of L's there. To clear whatever is in the column, you go to the top, very top, and you don't press delete. You press clear and hit enter. It will clear all of the entries. Go to the top of L1, hit clear, enter. So you should see something like this. You should see L1 and L2 for sure. Who's not seeing L1 and L2 right now? Anybody here that has that problem, you got to come and see me later on. I'll fix it for you. Let's type these values in. You got to use negatives. So -4, enter. -1, enter. 2, enter. 5, enter, right? Then you go over to L2, and that's where you're going to enter your y values. -5, 2, 1, -8. Okay. So we've entered them there. Before you do a regression, because we don't know exactly, we're going to do a scatter plot. Okay? That's where step 1 comes in. So we're going to go to y equals, clear any equations you have in there. Get rid of all the stuff that's in there because you're about to make your own. We're going to turn on scatter plot number 1. So you hit enter. Okay, so that should be highlighted when you move away from it. So go to it, hit enter. Once it's highlighted, you're good to go. The best way to do the scatter plot so you see all of them is use zoom. And then you're going to use the last option on the main screen here, which is zoom statistics. If you hit enter, you're going to see those points you just entered. These points, you're going to see them on your screen. It's the scatter plot. So which function or which regression do you think we should perform to have a curve that meets all of these points based on what we see? It's obviously a quadratic, right? It's the only one that would work. So I will one more time just say stat edit, right? And then enter x into L1, y into L2. So I'm kind of going off of this here a little bit. Then you go y equals plot 1 on, okay, and then zoom stat. Then you just look at scatter plot, then perform regression. I'm just going to call it reg. Okay. So let's do that. This one looks, right, looks quadratic. So we're going to go quadratic regression. So we go stat, calc, and we select quadratic regression from the menu. Make sure you write that down if you need a refresher. So I'm going to go stat, calculate. I choose a quadratic regression. Zoom stat doesn't work. Guys, listen carefully. Zoom stat doesn't work unless plot 1 is turned on. If you don't have plot 1 turned on, you're going to do a zoom stat and it's not going to do a thing because it doesn't know what do you want me to do. Oh, whatever is in plot 1, got it, right? So we're going to do a quadratic regression. So select quadratic regression. If all you wanted is the equation, you could just literally hit enter and it would do it, but we want this equation to be stored in y1, okay guys? So watch what I'm doing now. I'm going to make sure my calculator shows up entirely. Yeah. So you see L1 here? There's L1 and L2, L3, they're all L's are in here. So we're going to say, we're going to tell quadratic regression, second 1, right? Go and get all the x values from L1. You go comma, second L2, right? So y values are in there. And now another comma, and we need to tell it where to store that equation. We press alpha, right? Alpha and then followed by trace. If you press alpha trace, you can put it in any of the y's of your choice. I'm going to put it into y1 normally. So I'm going to select y1. And this is what you want to see before you run the regression, before you run the program. So I'm going to hit enter. And there you have it. And you want at least 2 decimals when you state your quadratic regression. Okay. Can I just, for those of you that are new, stat cal quad reg, I'm going to go L1, L2, Y1, okay? And maybe you need to tell yourself, to get L1, I need to press second, followed by 1. And then you will know what to do for L2. For Y1, I will say alpha trace. These are buttons, right? Alpha trace. And let's state our equation. Don't forget the y equals. If you were with me in grade 11 applied, you know that already, but you lose marks if you forget the y equals. So this would be negative 0.44 x squared. So right, it has the quadratic equation in general form there, and they give you a, b, and c. Plus 0.11x plus 2.56. So now you have the equation of the curve of best fit. They may give you more points than this. That depends on the scenario. So let's graph it and see if it actually does what it's supposed to do. So now you go to your calculator and you just hit graph. And there's your curve. Okay. It should be going through the points. In this case, I made it sure all the points are right on it, so it doesn't miss any of them. And go look at your y equals. Press y equals. You will see the equation pasted in here, right? It stored it into y1. So it uses every single decimal place. So if you keep scrolling to the right, you'll see that whole beast is in there, right? And that's what we want. We want it to be as accurate as possible. So use all the decimal places. Okay. Do you want to try one more time? Or do you think you're good? Yeah. Try it one more time with 34. Let's go to 34. Follow the steps. It's not a quadratic, just so you know. Let's see which one it is. Type in this into L1 and L2 and try to perform the regression for this one. See what you get. Then I'll show you the key in a bit. I'm just going to show you the key for this one. I feel like I should have that on the video, right? Because some of you might have to look back in like if it's weeks from now, right? So just do your thing until I'm ready here. Okay, so this is very important that you get this part right, where you know plot one, because you listen to this part, okay? If you're manually typing in an equation, you're doing this yourself because they gave you an equation. Make sure plot one is turned off. Why am I saying that? Because sometimes when you have this on, there's some kind of conflict with what you've entered, and they fight each other and you just get an error. So when you're typing this in manually, make sure you have this off. I don't have an equation right now, so I'm going to turn it on, because then I can use Zoom 9 and I can see, oh, okay, this is definitely a cubic regression. I didn't ask you, I said determine the equation that best fits the points, right? So it's up to you to figure that out. This looks like this, right? So therefore, cubic. So you have to do a cubic regression here. So I'm going to go stat, calculate, cubic regression, second 1, comma, second 2, comma, alpha trace, I put it into y1. There it is. It's a cubic. So you just need to rewrite this. So it's negative 0.67x cubed plus 12.78x squared plus 31 point, that would round to 50, right? X plus 289.001, so that's technically 0, 0. And if you hit graph, you should see that it's going through the points. It's a pretty good fit. We're good, we're in business, right? So now I can ask you for all kinds of things. I can ask you for the x-intercept. If I did ask you for the x-intercept, you want to make sure your y-min, you want to go below the x-axis, right? You want to be able to see that x-axis and then try to find it. I could ask you for the max. I could ask you for the min, for the y-intercept, for all kinds of things, just like before, because now you have the equation, right, to work with. So that is the point of this right here. I might post the answer, the key to this later. Some of you were working through this, so I'm just going to quickly glance through it. And remember, this is not a word problem, so you have arrowheads. It just includes everything. Domain is all real numbers. Put those away, guys. You don't have time to waste, guys, honestly. Just use the time wisely. Arrowheads, okay? That's that. Let's do a word problem, okay? Because that's, I'm just gonna tell you, they're gonna be problems. The nice thing is most problems, the most I've ever seen is ABC. Not like my questions like A, B, C, D, E, F, G, right? Like there's so many questions. So it's not going to be as overwhelming as perhaps some of my questions. So here it is, the first one. Note, you may be asked to create a scatter plot, right? You may be asked to create a scatter plot of your data in addition to any other graph you are asked to create. Same rules apply as before, as with equations only, okay? Couple of things I wanted to mention here. Sometimes the word millions come up. So let's say a company is keeping track of their sales. So Apple, first month after their launch, they sold 1.2 million. We will normally just enter 1.2 into our calculator for Y, but you got to know these are all millions. So you got to multiply them. Every number then gets just multiplied by a million. That's really what you want to know, right? So you multiply any Y value you get, you would multiply it by a million and then answer. So be aware of something like that. Doesn't happen very often. Also be aware of non-numerical values. So for example, they're keeping track of the months and the average temperature for each month. What would you do with January, February, March? You can't enter January, February, right? We wouldn't do that. So normally for January, you attach the number 1 to it. February, number 2 to it, and so forth. Okay, guys? So if I asked you what's the average temperature in July, what would X be? 7. You can use your fingers if you have a hard time. But then you would know, oh, they're asking for month number 7. So I just want you to be aware of that. I think most of you would kind of catch that. But so non-numerical values and then millions or billions or whatever, just be aware that we just need to be mindful of that. To be honest, if you answered, hey, month number 2, what were the sales? If you wrote 3.4 million, like if you wrote the word million after it, you're in business, okay? So you just got to make sure that you don't just answer $3.4. Like that's not, that they would probably catch you on that. Graph checklist, you know what? You already know all of this. So I'm just going to continue with the question right here. There you go. So we're talking about this chair right here. This inspired this question. Okay? What does it look like? Sometimes they give you hints, right? This looks cubic to me. right here, the side. This may look quadratic, okay, but we're talking about, we're repairing the wooden arm of a chair and takes careful measurements. If he can determine the equation, he can get a computer-controlled cutter to make a matching arm. The arm has a horizontal length of 45 centimeters. This was probably worth highlighting. Right? We know horizontally from end to end it's 45 centimeters. Okay? He finds the following data. So we have a horizontal position and vertical displacement. Just so you know, horizontal, vertical. Right? So this router is like cutting it on a board, so we need to know both directions. What regression would best fit this data? Justify your answer in words. When you have one like this, right, just make sure you go horizontal, goes into L1, and vertical goes into L2. And we will never trick you with this. The first column is always X. You can put an X there. The second column is Y. Similarly, if I gave you a table like this, sideways table, what would the first row be? That would be your X. The second row is your Y. It never deviates from that. Okay, so whether we give you a vertical table or a horizontal table, the first is X, the second one is Y. You don't have to guess. So let's answer this question. What I would suggest is let's put both of these points into L1 and L2 and see what the scatter plot looks like. So let's go ahead and do that. You can beat me to it. You've got the texting fingers. As if I don't text, right? I'm just not as fast as you guys. 0, 5. And I'd rather take a little longer and get it right than miss a 0 or a value altogether or a negative. And they have to match, okay? If one column is shorter than the other, you're in trouble. So I'm just going to check 0, 5, 10. And let's do our scatter plot. So let's say you're starting from scratch. I would erase, go to the y equals, erase anything that's already there, any equation. Plot 1 is on. So we're going to go zoom and press 9. Zoom, stat. This is just to help you out if you go through your notes. The scatter plot looks like a cubic function. So let's make sure we narrow it down. Since it has 2 turns. Okay, that is like a very distinctive property of a cubic. Like if it has 2 turns, it is most definitely a cubic. And we can tell, right, it has a turn here, right where it dips, and it has a turn up here. So we're quite confident that we're in the cubic function category. B, determine the equation of best fit. Write the equation and draw the curve on your graph. So we'll do that. We'll just go stat, calculate. Make sure you tell me you're using cubic regression. So I'm going to go stat, calculate, select cubic regression. Second 1, comma, second 2, comma, alpha trace, enter, enter, and there it is. Plus 0.06 x squared minus basically x plus 5. Okay? Plus 5. There's my quadratic, not quadratic, cubic equation. And I'm going to hit graph, and I see that it's a very good fit, right? It's a very good fit. Verifies it. What is the highest vertical displacement? Oh, second trace. So let's say vertical displacement throws you off. Well, they're literally asking what's the highest y value, right? They mentioned vertical displacement, like how much up and down, what's the highest. So we're going to figure out the max. And you have to be careful, because sometimes you think it is just going to be this point right here, but we have to compare it to our initial starting point as well, because they're very close, correct? Let's go find this max right here. Second trace max, and you go to the left of it, hit enter, go to the right of it, hit enter, enter one more time, and I'll write down the coordinate 5.05. So, is this higher than the initial point? It is, by very little, but we would say this one. So, the max vertical displacement is 5.05 centimeters. What is the zero of the curve? What does that represent? I think now we know what that means, right? The x-intercept. It indicates where the arm makes contact with the ground. So if you go up to the chair, I added this chair here just for you guys. You're the first group that has a picture. But for me, this is like when it reaches the bottom right here, it makes contact with the ground. That was the idea here. And you might think there's a little leg there. The question doesn't mention anything about it. But if you said, hey, where it touches the top of the leg, that would be fine as well. Let's go find the x-intercept, because it says what is the zero? y2 is equal to 0. Second trace intersect. And so you may have to make some adjustments to your window to make that happen. I let y2 equal to 0. I will chase the blue curve a bit, so I'll increase my x max. So let's go 60. There we go. Second trace 5, enter, enter, enter. Oops, it hits there, so I want to go here. Second trace 5. Jump the curve. I'm going to go up and down arrow, either one. It's just a little faster to get to here. Enter, enter, enter. That's 44.99. And watch this. Look at the second value. It looks like it's something other than 0, but that is 0. Okay, that is 0. All right. We're going to graph this thing, so go to 37. This is a study sheet entry, okay? Study sheet entry. I quickly made a note to myself to mention this. Scatterplot, if the province ever says that, they literally want dots, right? They want dots. If they want the line or curve of best fit, then obviously we would connect those points. Okay, so sometimes they'll say draw a scatter plot of this scenario. We just want the points to appear on the graph. Most of the time they ask for the line of best fit. Most of the time. But I just want you to know the distinction there. Let me put this over here. State the y-intercept. What does it tell us in this case? It is the initial, right? 0, 5 would be the y-intercept. The initial height of the cutting tool. Which is 5 centimeters. I'm just thinking now, I have to change the units of that thing because that's a very small chair. 5 centimeters. Anyways, that's maybe for my hamster. That's what it is. Chair for my hamster. Let's graph this. And again, I'm going to copy over the things I already know. The 0, 5. I know the one x-intercept at the very end. What was it again? 44.99? Yeah. I know 44.99. 0. So I'm going to find some more points here. So let's go and find more. We know the max as well, right? .05. So 33, 73, 505. I'm going to write that down as well. .3373, 505. This is the max. I need to figure out the min yet, so I'm going to do that as well. There is a dip here. Let's go find that one real quick. So second trace 3 for min. You got to go to the left of it. I wish you could do this faster. Touch screen would be nice. Right? Just press where you want to go and it will find it. The min is 11.21 and this is negative. But it's 0 basically if you round it to 2 decimals. So that's just 0. Okay, I'm just going to put that down. So here we go. This would be distance in centimeters. This is vertical in centimeters. Vertical displacement, good enough. I need to go all the way to 45 here, so let's see. 10, 20, 30, 40, 50. So I'm going to go up by tens. I will say this. I'll post the key. I would like you to try pages 40 to 41 if we run out of time, okay? Make sure you try that. I will post the key to that. I will graph this as well. So I need to go all the way up to 5 or 6. So 1, 2, 3, 4, 5, and 6. 0, 5 is right there. 11, zeros right here. 33, this would be 35 here, so 33 is right about there. 505, just a little over, and then 44.99 is basically 45. Okay, so we just bring it here, bring it back up, bring it back down. Okay. That's all you need. And don't forget your equation. Y is equal to something. Before we go, guys, domain would be 0 to 44.999. Range 0 to 505, right? Write an equation that would result in an arm that is taller. What would we do? Increase D. Have a good day, guys. Make sure you try those two questions, all right?